In this lesson, we're going to learn how to interpret and understand linear models. Every linear model has a lot of numbers and variables. The numbers and variables represent different things. In this lesson, our goal is to understand what each of these means. Let's take a look at this through an example. In our first exercise, Maria is draining her swimming pool. The volume of water in the pool is given by the function v of t equals negative 30t plus 12,500, where v is the volume of water in gallons in the pool and t is the number of minutes since the pool has been draining. We want to answer a few questions. What does the input represent in the context of the problem? What does the output represent in the context of the problem? And what does the statement v of 60 equals 10,700 mean in the context of the problem? The phrase "in the context of the problem" means we should be talking about the swimming pool and the amount of time. Let's take a look at what we have here. The first thing we need to do is understand the function. This function represents the volume of water in the swimming pool. Therefore, the numbers in the function are all related to the volume of water in the swimming pool. Here's our function. v of t equals negative 30t plus 12,500. We have t, which is the input, and negative 30t plus 12,500, which is the output. The input is the variable t. T is the number of minutes that the pool has been draining. So when we describe what the input represents in the context of the problem, what we have to say is it's the amount of time the pool has been draining in minutes. This information is always given to you in the problem because they will define what the variables represent, and the variables are the inputs and the outputs. What does the output represent in the context of the problem? Well, the output is what the function represents, the volume of water in gallons in the swimming pool. Therefore, when I describe what the output represents, I simply say the volume of water in the pool in gallons. Again, this information is given to us in the description of the problem because they will always define the variables for us. Finally, they give us an unusual statement at the bottom. v of 60 equals 10,700. If we look at what we started with in this problem, we had the function v of t equals negative 30t plus 12,500. We said that t was the input, and that negative 30t plus 12,500 was the output. If we match things up, we see that the input is 60, and the input is the amount of time in minutes. If we match up on the other side, we see that the 10,700 is the output. The output was the volume of water in the pool in gallons. If we put this information together, we can interpret this as the pool has been draining for 60 minutes, 60 was the input, and 10,700 gallons is the amount of water left in the pool. 10,700 is the output. This is how we interpret the inputs and the outputs in the context of the problem. Now we have a couple of more things we want to look at. We want to interpret certain numbers in the problem. What does the number negative 30 represent in the context of the problem? And what does the number 12,500 represent in the context of the problem? Again, in the context of the problem simply means we're going to be talking about the volume of water in the swimming pool. We know that our function is given to us in y equals mx plus b form, slope-intercept, which tells us the slope, or the rate of increase or decrease, and the y-intercept, which is the initial or the starting amount. In our function, negative 30 is the slope or the rate. We have a negative slope, therefore something is decreasing. Because this function represents the volume of water, Both of the numbers here, we call them parameters, the slope and the y-intercept, represent components of the volume of water. Negative 30 is the rate at which the volume of water is decreasing, and 12,500 is the initial or starting volume of water when we began draining the pool. When we interpret the parameters, negative 30 represents the rate at which the volume of water is decreasing. That's negative 30 gallons per minute. And the y-intercept, 12,500, is the initial or starting volume of water in the pool. When we began draining, we had 12,500 gallons of water in our swimming pool. And this is how we interpret linear functions. The next exercise is for you to try. Freddie is saving for a summer trip, so he opened a savings account at the local credit union, which is similar to a bank. The amount of money in his account is given by the function S of W equals 10W plus 50, where S is the total amount of money saved and W is the number of weeks since the account was opened. There are 5 questions for you to answer. Please pause the video here, see if you can answer these questions, and come back when you're ready to check your answers. Let's see how you did. We begin by understanding the function. The function represents the total amount of money that Freddie has saved, and we can identify the W as the input and the 10W plus 50 as the output. The inputs and outputs are defined in the problem. The input is W, which is the number of weeks since the account was opened. The output is given by the variable S, and that is the total amount of money saved. Next, we want to interpret the statement S of 5 equals 100. If we match up what we already know about the inputs and the outputs, we can see that the 5 is the input. And since the input is the number of weeks, we know that we have 5 weeks since the account was opened. 100 matches up with the output. That means the output was 100 and the total amount saved was $100. If we put this information together, we can see that after 5 weeks, Freddie has saved $100. Now let's interpret the slope and the y-intercept. We have the equation S of W equals 10W plus 50. 10 is the rate of change. It's a positive number, which means the amount saved is going up or increasing at a rate of $10 every week. The 50 is the y-intercept, which represents the starting or initial amount. We use this information to answer the 2 questions. What does the number 10 represent in the context of the problem? The rate at which the amount saved is increasing, $10 per week. What does the number 50 represent in the context of the problem? The initial or starting amount of money saved. When he began saving, Freddie had $50. This is everything you need to know in order to interpret linear functions. Remember, you can learn more about linear functions in Mr. Dorey's Algebra Handbook, available at www.doreypublications.com.